mine haulage system. Students, we are going to focus on this topic today, the haulage in the mines. So, the haulage means it is basically a transport system, the means of which are installed on the ground, which is on the ground, whether it is underground or whether it is on the surface of the ground. Okay. So, haulage means that there are different types of haulages. Most commonly the haulages were in earlier days were being used for the track haulages. That means, on the track the tubs used to move by manual loading, the truck was getting the tub was getting filled up, and then it was getting transported by means of rope haulage system or by locomotive haulage system. Locomotive used to pull it in case of underground coal mines, where there is a danger of gas etc., the flammable gas etc., like methane and carbon monoxide. So, there the use of locomotives, diesel locomotives are prohibited, even electric locomotives are also prohibited, because it may cause the spark on the overhead lines. Even battery locomotives have to be very intrinsically safe construction, and also it should be flame proof from its design. So, then only the battery locomotives are being used. Flame proof means suppose the basic difference between intrinsically safe and flame proof is that the flame proof means even if the flame is getting generated inside the concealed parts of the electrical device, its flame will not come out, nor it will allow the gas to go inside to get burnt when the spark takes place. So, that is flame proof. And intrinsically safe means it is made in such a design that the spark is so feeble, the spark is so weak that it will not be generating the heat to cause any flammable gas to burn around. So, that way it is intrinsically safe anyhow. So, I am coming to the haulage portion again. Haulage means it is the transporting system on the ground. On the ground means it is installed on the by taking the support of the ground, whether that ground surface is in underground or that ground surface is in open cast on the surface exposed to the sky. The types of haulages are divided in 3 sections for the mines. One is from mining phase, the material is being taken out from the mining phase. So, that is called section or phase haulage. Then it is transferring to one intermediate place, where the panel, that means panel is a larger area of the mining phase, particularly in board and pillar, so many pillars are forming one panel, whereas single pillar is forming the point of picking the material, that face, that is forming the face. The single pillar is forming the face wherever the coal is being cut, whereas from the entire area having the so many pillars, that is called one panel. That panel is made depending upon the controllability of the ventilation from the each galleries between the 2 pillars. The ventilation air should go properly with the right speed, that is 1.7 meters per second speed of the minimum ventilation air should pass through as per the DGMS. So, accordingly the panel designs are made, the dimensions are taking place according to fan capacity and my production need etc. So, that is called panel. Then material, then from panel it moves out to the main conveyor, which is taking the material, or main transportation system, which is taking the material to the surface. That also includes the hoist system, okay, the hoisting of the material on the top. So, the mining phase the section haulage has to have the capacity of taking and transporting away the material immediately through the panel haulage. From panel haulage it should move to the material to the to the main haulage. So, the main haulage should be capable of having, there has to be a storage in between panel haulage and main haulage, because main haulage is the has got tremendous limitation. The shaft diameter is fixed, the cage capacity is fixed, the skip even if it is skip winding, not the cage winding, then also the capacity is fixed, its winding time is fixed, it cannot be changed. So, the material handling capacity of the shaft or the cage system or the skip system in the main haulage is not having much of flexibility. So, before that there have to have the material always available to the main haulage, there has to be buffer stock which is kept in the bin inside the underground mines, and the intermediate haulage is receiving the material, it should make the face haulage always free of that, the face haulage should not get jammed because of any limitation on the intermediate haulage system, otherwise the production of at the face will stop. So, the haulage has to go on taking the intermediate haulage has to go on taking the material continuously from this section haulage and then storing the material in between main haulage and intermediate haulage. So, these are the types of haulages. Phase haulage has got the track mounted system, and in track mounted system scrappers are there, rope haulage system, even scrappers loading is also based on rope haulage only, sorry, track haulage only, and rope haulage systems are also track haulage basically, and locomotive haulage needs definitely the tracks, you understand very well that part. Whereas, in case of tire mounted haulages, LHD and low profile dumpers are used in there are some instead of wagons there are some terms called the this car. So, car is having little more capacity and tubs are having 1 ton capacity in underground mines. So, load hauled LHD is a load hauled dump, it is a kind of loader, low profile loader which dumps the material onto the low profile dumper, and that dumper takes out through the spiral ramp or through the zigzag ramp inside the underground from the underground to the surface. Then there is conveyor haulage system which is most preferred on inclines. Inclines means 1 in 4, 1 in 3, 1 in 2, 1 in 2 is around 28 to 30 degree inclination, which is much lesser than the angle of repose of the material, that is 38 degree, and conveyor inclination has to be kept below angle of repose well under angle of repose. That means, when angle of repose is 38 degree, the maximum conveyor angle with the horizontal can be installed is 32 degree, not more than that. So, that way the most common is armored face conveyor on the long ball face for the face haulage, whereas for intermediate haulage again conveyors are used, and for the main haulage also scrapper haulage, scrapper loading machine mine tubs on track, crusher bin etc., then it is going to from mine tubs it is getting transferred to crusher bin in the underground itself, in the underground crusher bin only. There in metal mines this is most preferred, because in coal mines the installation may not be that tough, that is strong, because the rocks are softer. So, crusher bins are avoided in underground, whereas in metal mines it is quite common, the rocks are very tough and hard because of its igneous origin, or maybe even metamorphic rocks are quite tough, some of the metamorphic, whereas some of the metamorphics are because of its weathering it is weak also. But in tougher ground the crusher bins are provided inside the underground, that is called transfer bins, and those bins are kept as cushion in the underground mining coal in the underground metal mining. This is the scrapper face diagram. See the scrapper bucket is there at the bottom, which is like folded hand like this, and it is scooping the material, and it is pulling the material on the ramp shown with the scrapper this motor, wherever the motor is there on the track, that is track mounted, and that ramp, on the ramp the material is dragged up by the scraper bucket with the help of ropes control, and that ultimately is putting the material into the tub standing below behind the crusher the ramp, the slide ramp for sliding of the scraper on the ramp and to take the material up, and then it is allowing the material to fall through a hole on the top of the horizontal portion of the ramp. There is a hole, rectangular hole, through which the material falls into the tub, and this is basically track system. So, this is the diagram of the scraper bucket. You can see on the bottom hoist line, this is the plan view. On the bottom hoist line shown in the diagram, the scraper bucket is there. Number 1 is the scraper bucket, number 2 is the hoist rope drum, number 3 is the hoist rope, number 4 is the return tail pulley, and steel ramp is shown number 5, and after that tubs are there. So, you can see the hatchet portions are standing, hatchet portions tubs are standing, that is the loaded tub standing on the straight line, whereas empties are waiting on the other side. With the help of switches, rail track switches, it comes to the alignment of the scraper back on the back side of the scraper, and then it is getting loaded as it was shown in the previous diagram. Scraper buckets are like this. One is the cutting edge scraper bucket, this is the ripper, that means finger type like this. So, ripper bucket, and the ropes are tied on the narrow portion of the beam shown in the front side of the photograph or diagram. Similarly, there is a horizontal bar shown with the left hand diagram. So, that bar is tied with the rope, and then it is allowed, and bottom is also tied somewhere at the bottom portion, so that it is forming the, or actually on other side of the plate, on the other side of the, whether B is written on other side of the plate, the other hoist rope is tied, and from the narrow portion where bracket has been made. So, there the one end of the rope is tied, and other side the other end of the rope is tied, and then it is maneuvered by pulling the rope or releasing the rope from the motor. This is a rocker shovel. So, you can see how does it load on the back. So, on the back side of the rocker shovel, where the bucket is shown by dotted line in the lifted position. So, there it is, there tubs are standing, where 1.6 meter height is written on the right hand side of the left diagram. So, there the tubs are placed, and it is getting loaded by the lifted bucket onto the tub. This is a gathering arm loader, actually provided with a boom on the back, and that is having the flight conveyor or chain conveyor. So, gathering arm as it has been shown like this, two sides it will be collecting the material like this, and the jib will go inside the blasted material, the bottom jib like this, and it will be having the pan, inclined pan like this, and it will be, there are two arms gathering like the material like this, and then it is lifted up and put, and from the lifted material by gathering arm will be dragged up to the bottom portion of the chain conveyor. From there it will be further dragged on a deck of the conveyor by the flights. Flights are the horizontal members of the conveyor put tied with the chain, that is trapping the material to pull ahead, and that is falling the back side of the boom. There will be a tub, that tub will be getting filled up, or there will be some other conveyor system. Next please. Normally tubs are placed on the back of this. Here also you can see the loading conveyor on the back of the machine, and front side there is a pan like this, like a spade, and there are two rotating gathering arms. So, when it rotates, it will be collecting the material and put to the conveyor system. The conveyor, loading conveyor is shown, that is in lowered position now. When it is lifted, when it is to load the tub, it is lifted up above the tub on the back side, and the front, that boom on the top, the cutting head is having tungsten carbide bits, the tungsten carbide toothpicks rather, and the head is rotated like this, then it will be cutting the coal. This is basically a drifting, this is used for drifting purpose. That means, on softer rock, when you are heading the drift or heading the drivage, then only it is used. It has got limitation of swinging both sides. So, it will be making the passage only, it cannot be used on mining phase. Next please. This is a tunnel borer machine, which is the front portion, circular portion is the cutting, having the cutting bits, which will be coming in contact with the rock, and it will be cutting the rock horizontally, and at the bottom again the gathering arm wheels will be there at the bottom like this. It will be lifting the material to the belt, and on the back side there is a conveyor belt system that will be conveying the metal on the back. This is a continuous working machine to the diameter required for making the tunnel or drift or drivages. These machines are being used in very large way. This is most commonly used these days for driving the tunnels inside the hilly portions to make the roads, particularly by Border Road Organization of India. So, this is a load haul dump machine which is having low profile. You can see how it is so low, and bucket size is big, but see how it is big, and this is tire mounted machine, and on the back there is engine, at the center there is a cabin for loader operator having canopy on the roof on the top, so that anything falling inside the mine from the top will be I mean to say that fall will be protected to come on the operator head by the canopy on the top. See, this is the dimensional diagram of the loader load haul dump. You can see the dimensions are how conducive to the atmosphere in the roof height etc., inside the underground mining. So, this is hardly to 3.6 up to 3.6, maximum in lifted position may be around 4.2 meters or 4.5 meters maximum, and it is having swiveling at the center. You can see how it is providing the radius of curvature so low, so that its turning is easy inside the limited place of underground mining. This is the low profile dumper. See how it is low. On the back end, see the front side window type of portion seen is the operator's cabin. After that, tire is being seen on the right hand side. After that, there is scoop body of the dumper. So, that dumper scoop body is getting loaded by the load haul dump machine, and then it is transporting this material to the top of the top of the mine, that is surface, on the surface by spiral road in the underground itself, or the zigzag road like this, the hilly road which is made like this, okay, that is zigzag road. Next please. This is the dimensional diagram of the load low profile dumper. You can see in lifted position how much height it is covering. When the back body is lifted, it is shown by dotted line, and it is hardly covering 3.6 meter, maximum 4 meters of the height in lifted position. That way it is used in underground. And see, you can ask, sir, when it is taking the material to the surface, why does it need the low height? In underground, the roof height is the limitation, and suppose there is a crushing bin, the crusher provided on the storage bin, on the top of the storage bin. So, there it needs to dump instead of bringing to top. From that bin, the skip loading will be there. Skip loading then skip will be taking the metal to by hoisting system to the top. That case, dumper will not go up, dumper will be just operating on a certain level of the mine workings. This is the coal shearing machine. On left hand side, the head is there, which is having tungsten carbide picks, that is cutting the coal. Vertical black portion face of the coal is shown. Then at the central portion below the rotating beam of the cutting head of the coal shearer, there is a belt kind of thing seen at the central portion, which is little in darker place, which is not that clear, but it is labeled like armored face conveyor. From the bottom you can see that is armored face conveyor, that because of the screwed head profile, of the cutting head, the material cut is dragged inward and it is allowed, there is a plate in below that, and that is allowed to take the material to on the armored face conveyor, and armored face conveyor is conveying to the next. This is the face transportation system, or this is the face haulage basically. It is transporting to the panel conveyor, that may be belt conveyor henceforth, and on the side these steel cylinders shown are basically of the shield, the hydraulic shield which is supporting the roof above this. You can see the hydraulic shield on the top of the topmost portion, where the hydraulic shields are supporting the roof. Entire system is integrated. When the face is eaten away longitudinally, then it needs further moving ahead. So, to come in contact with the face to cut further. In a cut, normally it is cutting around 1.2 meters, 1.5 meters thickness to cut the coal, and it is going ahead, going and cutting maximum 1.4 meters, 1.6 meters, like that. After that it is getting cut, and again it needs to move ahead. So, it needs it is moved ahead by hydraulic jack system provided at the bottom base of the hydraulic shields. So, hydraulic jacks are pushing entire thing ahead, not only the shields, it is also pushing the coal shearer head, it is also pushing the armored face conveyor towards the face to come in contact for further cutting the slab. So, rope haulage, direct rope haulage, endless rope haulage, over rope, under rope, main and tail rope haulage, and gravity haulage. These are the haulages. Direct rope haulage is forming sometimes the part of intermediate haulage, sometimes face haulage also, and sometimes male haulage. It is very flexible kind of haulages. Endless rope haulage is forming the part of intermediate haulage. It is sometimes over rope, sometimes under rope provided, depending upon the design and their convenience. Main and tail rope haulage is another type of haulage. We will come to know it is the endless. It is also endless rope, but rope is not endless. There is no clamping done with the rope. The tying of rope is done with the wagons. So, that way it is forming the endless link. Gravity haulage. Gravity haulage is up and down, two types of the tub, loaded tubs is going down and empty tubs are getting pulled up, or empty tubs is going down, then loaded tubs cannot be pulled up because empty tubs are having lesser weight. So, when loaded tubs goes down, then empty tubs come up. So, this kind of gravity haulage is used in adits, where the inclination is around say some inclinations are given in the adits. This is the endless rope haulage. Okay. So, it is actually undulated. Suppose if it is undulated ground also, having the inclination at any of the places not more than 1 in 10, there it is most commonly it is used. Otherwise, if it is more than 1 in 10 in any of the portion of the track, it will not work. Direct rope haulage, simplest system consisting of pulling rope. It is more of the deepness, 1 in where the inclination increases for more than 1 in 6 or so. That means, if it is becoming 1 in 4, 1 in 5, 1 in 2.5, then the inclination is increasing. So, 1 in 7, 1 in 8. So, there the direct rope haulages are used. There are two sides wagon movements, whereas in endless rope haulage that is a circular movement, oval movement rather. Okay. Advantage of direct rope haulage is that it is very powerful to put, rather it works well on the dip of the along the dip of the seam, particularly when the loaded tubs are pulled up for connecting to the intermediate haulage and from the mining face, and the empty tubs are to be sent to the working place along the dip direction of the seam. Coal mining, this is very common in coal mining. Disadvantage of direct rope haulage is that, see, its inclination is high. So, when any rope breakage takes place, the derailment takes place, and that is damaging a lot because of more inclination, it gains the speed. So, that is why at the last wagon there is a back stay which is put, a rod, thick rail sort of big piece is there around say around 0.8 meters to 1 meter long. So, that is put. So, once the wagon is moving up, when it is getting discharged because of wire rope breakage. The latch, the put this is latch, this is a latch, that is monkey catch also it is called. So, when wagon rolls down, it will be holding the ground, this is pointed, it will be holding the ground to arrest the wagon movement downside. So, that is called monkey latch or whatever this device is called, it is given here. Okay. Monkey catch, sorry, not monkey latch, monkey catch, or it is the back stay, it is called back stay also in simple language. Okay. Next please. Double drum balanced rope. Single drum is there to lift the two types of this one wagons, lifting of load, allowing of, then it is put to the other side, allowing the load. That single drum is rotated, one rope is going like this, one rope is going like this, other end of the rope is going like this from the bottom. So, the empty is pulled from the bottom rope and the loaded tub goes from this one and vice versa. When this is getting when empty is going down, then loaded is coming up. Normally, in direct rope haulage, the loaded comes up, the loaded wagon comes up and empty goes down to the mining phase. So, the loaded wagon when it is pulled up and empty is going down. So, empty is having also some load. So, that is pulling the other side of the drum downside by gravity. So, that is causing, that force is coming on the drum, that is giving additional force to pull up the loaded wagons in addition of the horsepower of the engine. So, that way it is pulled up and the torque required is less. Advantage, disadvantages are there, it is simple in maintenance, less power consuming because of empty tubs going and it is creating positive torque to pull the loaded wagons, loaded tubs, but it needs wider road because of double side, and in case of hauling engine breakdown, both sides are affected. This is the direct rope haulage diagram. You can see on left hand side, this is the plan view. So, on the left hand side the two drums are there for double rope direct rope haulage, double drum direct rope haulage, and it is connecting to the, once it is taken out from the mining phase coming to the drum side, the other part is the horizontal, this is the dip direction, this is the dip direction shown. So, along that the rope, two ropes are going, once the tubs are coming up, that is put to the horizontal side and that is coming to the intermediate haulage. The loaded tubs are coming to intermediate haulage and empty tubs are going from intermediate haulage to the phase haulage. This is endless rope haulage. You can see the loaded tubs are there, return pulley is there on the last having tension system. Otherwise, there has to be tension on the drum of the driving Clifton pulley system where driving motors and engines are there. So, on the pulley there has to be a load because inclination is not much here and moreover it is undulating. So, the wagons are going to lower portion, it is creating tension, but when it is coming to upper portion, it does not create the gravitational pull on the rope. So, there has to be a tension like your aerial ropeways, there will be a gravity take up tension system at the end of the any aerial ropeway. You will find out at Dongargarh also in Chhattisgarh and maybe in some of the areas of hilly areas in Uttaranchal areas also when you go for tourism, and the bent pulleys are there, the systems, the empty tubs moves on the left hand side and the loaded tubs moves on the right hand side. Yes, the black one is the loaded tub. Features of endless rope haulage, it cannot negotiate for more than 1 in 10 and its speed is there 3 in 7 kilometers per hour and over rope, under ropes are types of there. Next please. This is the tension arrangement, you can see how the gravity system is working for giving tension. The rope is there, the endless rope is shown at the center of the pulley is shown by black thick line, horizontal line. So, around that the rope is moving like this and pulley is here and the pulley is fixed to the carriage and carriage is kept pulled by the weight system. So, that tension will be there on the rope. These are the clamping system of wagons, different portable clamps are used. One end is attached to wagon, another end is attached to, see wherever in bracket where it is written in bracket A, that portion is attached to wagon and the rope is clamped at the bottom with the help of levers, etc. This is another clamping system. The chain is going to tub and the cam type of clamp is creating grip on the rope by pushing down the rod. This is overhead rope haulage. You can see normally the rope is at the bottom of in between the tracks of the the rope in endless rope haulage is normally at the in between the tracks at the lower portion, but here the rope is on the top and it is connected with chain. The tubs are connected with chain with the rope to pull hither and thither whatever direction is there. Advantage of endless rope haulage is speed is slow, it is it takes lesser power motor it requires, and it is very good for undulating ground where ups and downs both are there, whereas direct rope haulage is only for up ground like this, steep ground like this. Next please. Disadvantage of endless rope haulage is that when rope snatches or breaks, it will be paralyzing both the sides, that is the biggest disadvantage, no production will be there, and it is not suitable for steep gradient, and it needs lot of arrangements like clamping clips etc., then bent pulleys, then tensioning arrangement. So, these things are not there with in case of other haulages. Main and tail rope haulage, see the drum is there and same drum, there are two types of drums, there are two different drums, one end is going to one set of tub one side, another is going to other set of tub other side. Just so next please. Next diagram, see you can see the loaded tubs are there. With the set of tubs you can find that rope is tied with the left side of the drum, sorry tub, and on the right hand side the another end is tied with the right hand side of the tub, the set of the tubs. And the diagram it is a plan view basically, it is as seen from the top, and there are two drums shown by the rectangular portion. So, that rope is getting pulled from either of the, if the to move the direction it has been shown, then same unloaded tubs are unloaded on the top, and after that it is the empty tubs are again lowered down by this lowering of the wagons by reversing the drum direction. Next please. This is the arrangement of the pulley at the end to give tension, and there is the braking system with the gravity haulage system. So, you can see how the pulley is fitted, and on the around the pulley on the periphery the rope has been put for the gravity rope haulage. The gravity rope haulage is working without any motor or engine on the gravity itself. When loaded tub goes down, the empty tubs are pulled up. When this loaded tubs goes down this side, then empty tubs are pulled from other side. So, this is used in specific cases only where gravity is made in favor by imbibing in the mechanism system. Next please. This is the gravity haulage. You can see on the right hand side there is a pulley, which pulley was shown earlier in the previous diagram, and top portion is showing the plan view and the bottom portion is showing the incline. So, this is most useful in edits etc. Next please. Locomotive haulages. See basically there are two types of locomotives, one is electric locomotive, another is the diesel locomotive. Diesel locomotive is used only in metallic mines where there is no gas dangers are there. The electric motors are also used in case of, there are two types of electric motors, one is the battery operated electric motors, another is the overhead line system like railway engines. So, that railway engine line systems are used in underground system with pantograph, whereas battery locomotives are used with intrinsically safe and flame proof constructions with the locomotive, which can prevent which will not be contributing negatively to the gases, to burn the gases to cause the fire etc. in underground coal mines. So, battery locomotives may be used in lesser degree of coal mines, but there is nothing called non-gassy mines in coal mines as per Director General of Mine Safety. So, battery locomotives are normally avoided. These locomotives are electric locomotives are used on surface more than the underground. Even diesel, even locomotives are not the most common haulage system is the rope haulage in coal mines. Suitability of locomotive etc. has been given 1 in 15, most suitable, it should not exceed 1 in 15. 1 in 15 gradient is higher than 1 in 25, most suitable for 1 in 25. And next please. So, features of locomotives are given, it is the electric locomotives are having batteries which are rechargeable and that takes minimum 8 hours to get recharged, then only it can be operated, that is a drawback. Next please. Features of locomotive in mines, again it has been shown. Battery locomotives features have been shown here, how much weight is there, how much powers are there, kilowatt power it generates, then smoke hits whatever silencer smoke hits preventions are there in the mines. It doesn't the silencer does not allow any incandescent particle to come out of the silencer to cause the sparking of the gases outside. Then braking systems are there in locomotives. Next please. This is the, we can see the how the drifts has been shown at the bottom. For the drifts are driven in parallel to the strike direction of the ore body as shown in the stope area here, and that is covered by locomotive, whereas cross cuts are bringing the ore from the stope area to the drift line, and from drift line the locomotives are taking the material to the shaft next for loading. Next please. This is the underground mines tubs and cars shown, how it is getting hauled on the track. Next. This is the conveyor system which is used for conveying the incline on the incline, the material on the incline upper side. So, this is the conveying system, this is most useful in case of adits and inclines for underground mining, and surface mining it is very common. Next please. These are the stacking conveyors. Next please. These are also arch shaped stacking conveyors which swings on the wall and the line with the help of wheels, and then it goes on stacking. Next please. This is the pipe conveyor. So, this is not by structure, it is pipe, it is made of rubber, it is flat, but on the troughing idlers it is flat at the discharge point, at the receiving point of the material and at the discharge point of the material it is flat, but when it is covered with hexagonal idlers, then it becomes folded to form the pipe and the material remains inside to go. It does not allow any spillage on the spillage of the material outside, and very easy in maintenance. Next please. So, this is the pipe conveyor, hexagonal things have been shown, the idlers have been shown. In normal cases the troughing idlers are shown like this to take the material and the top side is open, but in case of pipe conveyors all side it is covered by the idlers. Idlers are, the hexagonal idler is causing the folding of the belt when it moves from the receiving the material, after that it moves, there it is flat, but when it is moving through the hexagonal periphery of the hexagonal portion of the idlers, it is getting folded, again it is getting unfolded at the discharge point. Next please. This is the rift conveyor for the higher inclination, so that it grips the material to push up and then it transports. Next please. Uses of belt conveyors in continuous transport system, bucket wheel excavator. Next please. In cement plant, feeding limestone to the mines on longer distance of 10 kilometers, processing plants where continuous feed is required from one step to other, conveying along inclines in adits as I have told. It is continuously used for stacking purpose. Next please. It is also armored face conveyor is used also on the long wall face, as I had shown on the previous diagram with the shearer machine, the photograph, previous photograph, and it is taking, you can see there is a two parallel lines, the coal cutting machine is cutting a slab. So, the face is curved little like this, so that the cutting machine goes on cutting the slab. So, it is curved, the parallel line is the armored face conveyor. After that it is putting the metal on the gate conveyor is forming the intermediate line, the armored face conveyor is forming, the armored face conveyor like this is forming the phase transportation system. After that gate conveyor is taking to the main conveyor through the incline to the surface. Next please. This is the conveyor system with surface miner for loading of dumpers etc., and dumpers are also forming the haulage system in open cast mining, for there it is used. Next please. It is stacking the material, the surface miner is working as a stacker, and at the same time it is eating away the material from the floor of the coal. It is used on coal bed and it is stacking like this on the side, so that loader and dumper will come and they will take away the material. Next please. This is the bucket wheel excavator. You can see on the right hand side there is a bucket wheel. So, that is lifting the material in from this side, if you see the picture, the anti-clockwise direction, and it is putting the material the taken material from the mining phase on the belt conveyor boom. From there it is moving to the left side, the horizontal part of the conveyor, then from there it is moving to the main line conveyor. So, it is phase conveyor system to the intermediate conveyor system with the horizontal system. It is also provided in the stacker only, sorry, on the bucket wheel frame only, and then it is going to the line conveyor, which is the main haulage system, you can say. Next please. This is the photograph of the main bucket wheel excavator. Left hand side you can see the bucket wheel working, and it is putting the material at the central portion on the right hand conveyor. Right hand conveyor in turn is loading the material onto the line conveyor, which is going far distant plant etc., where the processing takes place or coal washing takes place. So, this is also used on softer rock, because bucket wheel needs the cutting strength. So, that needs on softer rock it can work better, and this is used on lignite and coal mines. Next please. This is the bucket wheel excavator used for stacking purpose. Next please. This is, see how the stacker is working, the inclined belt is bringing the coal, and then it is the belt is going down, empty belt like this, and it is allowing the material to fall, and the boom is there which is stacking the coal. So, this is being used for stacking purpose, and this material is coming from the main line of the main haulage of the coal mines. Okay. Next please. This is the skip conveyor hoisting system in inclined shaft, more than 50 degree at more than 50 degree angle. Next please. This is the skip system which overturns like this and material falls onto the bin. Next please. Type of winding, that is the skip winding and cage winding, that is a given, just there are two types. Next. This is the headgear pulley system for hoist system, and the cage goes up and down, or skip even goes, that is the shaft. The structure, vertical structure shown is around the shaft, and shaft is underground. So, the hoisting system takes place in that, and this is the hoisting drum connected with the motor. Next please. This is the Cope winding. Cope winding, in the previous diagram you see the blue portion at the bottom is a hoist drum, which is rotating and allowing the rope to go up and down for hoisting system through the pulley to the cage or skip in the vertical shaft. Next please. In case of this, that there is no in the this is also for the hoist drum system. Next please. This is not the Cope winder, this is ordinary drum winding system. Next please. This is the Cope winder. Here there is no drum, hoist drum. On the left hand diagram, sorry, the right hand diagram, a hoist drum system has been shown for the hoisting of the drum. Whereas in case of Cope winder, the top pulley itself rotates with the motor, and the rope is passing through that to lift the cage up and down. So, there is no hoist drum separately installed on the surface of the ground. The driving pulley is given on the top of the headgear, where the structure is there, the steel structure. On the top of that it is provided with a motor. So, it is the pulley is only rotating on either the sides with single wrap on that. So, this is Cope winder. Next please. Cope winder advantages are there, it is quite simple in structure, and to maintain it is easy, unlike the drum winder. Next please. Thanks to all of you.